Welcome to the session. Thank you for attending. This particular session is where we're going to go a little bit deeper under the covers of Shielded VMs, Guarded Fabric, and the Host Guardian service. My name is Dean Wells. I'm a program manager in Windows Server, and with me I have...
My name is Lars. I'm a program manager on the Hyper-V team, actually.
So between Lars and I, we own the end-to-end scenario for Guarded Fabric. Lars owns the pieces within Hyper-V itself, and I own the stuff around the Host Guardian service with attestation and a number of the components that make it secure. So here's what we plan to do today. This is going to be a very demonstration-heavy session. Because we've got this auditorium, this is one of the first ones where I actually think we can make it a bit more interactive. It's not one of those ones where you feel like you're at a Beyonce concert. This feels a little closer. So if you want to ask questions, please just raise a hand. If we need to finish a sentence, we'll do that, and then I'll give you the floor to ask a question, and I'll do my best to repeat it over the mic. But it's going to be demo-heavy, and if we can make it, excuse me, interactive, all the better. So I'm not going to go through the same mundane security slides because you've probably seen those 11 times by this time, I would imagine. I am going to go through just a couple of things, again, to tee up the context. So first and foremost, what on earth is the attack vector that shielded VMs are attempting to defend against? Well, Lars is going to show you that as the very first demo. Effectively, what we're going to do is we're going to use Fabric admin privilege to extend an admin privilege into a guest operating system running a workload of our choosing. Now, the typical one that we choose is the one that scares most folks. That's an Active Directory domain controller, because as you can well imagine, if I get the secrets from an Active Directory domain controller, I have the keys to the various kingdoms over which it is a domain controller. So we typically attack Active Directory. We'll show you how we do that and what the end result is, because we have the ability to extract passwords from it. Not instantaneously. It can take weeks or months, depending on the password strength. It's a brute force attack. The Fabric admin, however, is able to do something that the system doesn't readily audit. It can mount the VHDX of the virtual machine and take the whole VHDX home on a USB stick, mount it at home, and now he just sits there brute forcing it in his own time. Do you understand the attack vector now? The trouble is nobody sees this happening because it's kind of like Neo, being the domain controller, and the Matrix. We stole it at the Matrix level. Nobody saw what was going on because we weren't operating in the same spatial time or whatever you want to refer to. Who am I protecting against? Well, I think it's fairly obvious. You can infer it from the first one. Fabric administrators, SAN administrators, network administrators, backup administrators. Why would I want to shield a VM? So that that can't happen. OK, that's that context established. So here's a summary of the high-level attack types. You've seen this one before, but the stuff on the left is what we've been working with for donkey's years. We've been defending against this, and it's a never-ending game of leapfrog. I would argue that Microsoft is well in the front at this point with Credential Guard, Device Guard, both of which are hypervisor-enforced capabilities, using virtualization-based platform technologies for security purposes, both in server and in client. That's a pretty clever incarnation of those particular platform capabilities. They're typically used just to run virtual machines. We use them to protect secrets and credential artifacts from rogue software running with admin privileges or from a malicious admin. So there's a large number of components doing that. The stuff on the right is what we're here to talk about today. This is an attack vector that the industry, up until the release of Shielded VMs, has had no answer for whatsoever. This attack vector is not specific to a domain controller. SQL is just as susceptible. Any workload, Microsoft or non-Microsoft, doesn't matter. Any hypervisor, Microsoft or non-Microsoft, doesn't matter. Many people say to me, why don't I just encrypt the disk on which the VMDK, VMware, or VHDX resides? Well, that doesn't do anything because the attack vector is from an admin. The admin lives inside the crypto bubble. The machine is already decrypting that disk in real time for the admin so that he has access to those files. We can't protect against them unless the encryption is being handled within the context of the VM using keys that are not available to the admin. That's what we set out to build. That's what we achieved. So what do all these attacks have in common? I think it's kind of obvious by this point. It's admin privileges. The problem is that we gave those privileges out way, way, way back. I've polled the audience in a few sessions, and I've had people go back as far as OS2 LAN server, 3+ open, 3+ share. Really old crap, LAN manager, Windows NT 3.1 advanced server. I would question the advanced part there, but Windows NT 3.1 server. Windows NT 4, Novell NetWare. Every single one has an advanced user, some concept of a root, supervisor, or admin. There's no exception to that. We can't just take it away. We actually thought about it for 5 minutes. What about if we release a copy of Windows with Active Directory that has no notion of an admin? You can imagine the giggles that went round the room of the engineering discussion. Nobody would buy our software. So we can't just take it away now. Everybody is used to this model, so we have to do things to protect the use of those privileges. That's what privileged access management does. That's what just enough administration does. And then we prevent people from stealing artifacts that allow them to abuse those privileges. Shielded VMs sets out to put protections around the container, the bubble. Ooh, bad choice of word, container. No. Shielded VM sets out to put shields around the matrix so that they can't get into it from the outside. You get into your guest workload in the same way you always do. You RDP to it. You SSH to it. However you access it, WinRM, it doesn't matter. We want to stop the Fabric admin leveraging a privilege in a different domain, an entirely different security realm, and then abusing that privilege to get inside these workloads. That's the goal. So Lars is going to show you the attack vector, assuming the demo rig is now up and working.
Yes, it is.
Fantastic.
Actually. So let me switch over to number 6 here. And since I'm a malicious Fabric admin, I have to put on my attacker hat here. So whenever I wear this hat, you guys know that I'm up to something no good, right? So.
Can we just be clear? He's a malicious German Fabric admin. Now, you can take that for what you will, but I'm scared.
Yeah, and you should be. You should be. So what you see here on this demo machine, I have a couple of machines running. It's actually a nested environment. I have a few domain controllers running there. I have my guarded hosts even running on this environment, and we'll talk a little bit about that later on. But what I want to show you now is the first part where we have this one domain controller here. And if I'm an administrator on the Hyper-V box, I can simply go ahead and say I want to export it. The nice thing about the exporting part is I can choose any directory, for example, the export directory here, and let it do its thing. If I scroll over a little bit over here, you can see that it's starting the export. And the nice part about that is you won't really notice any downtime for the VM, right? Because it's just going, it's just going out and taking a checkpoint and exporting that particular checkpoint. So you as the user of that workload, of the domain controller, don't notice any particular downtime there. And then I can go ahead. I did the export earlier, so we don't have to wait for that to finish. Then I can go ahead and simply, this is the exported folder structure, simply mount the DC01 BHDX with a mighty double click, go to the Windows directory, go to the NTDS directory, copy my NTDS dit out, and where was I? And go ahead and paste that on a flash drive or paste that on any directory that I have, where I have this nice crack ADDB tool that I can then run and get nice passwords out of it. So far so good. We've seen that, right? We've seen that in the keynote. But what the interesting part is here, with those passwords, I can actually persist my attack. And that is one thing that I can show here. If I now take the SQL admin password, I can go ahead and log into a SQL box that is a SQL virtual machine that is also running here. So I can log in. Let's take this one. Enter the password. It's a nice full UI server, so you can actually see what I'm doing. But yeah, it's just to prove the point, right? It's not that it's not doable with any other server SKU there. So I can simply start up regedit and go to the run key for the user. So remember, I'm logged in as the SQL admin right now. And if I add a particular script here, a call to a script, so I can just create a new string value here that simply says, OK, run PowerShell for c:temp attack.ps1. So there's one part of my persisting the attack. And the second part is simply using Explorer, going to C, going to temp, copy, and paste my attack host script here. See, I misspelled that, so it should be attack host ps1. And what would that do? Whenever the SQL admin now logs in, what happens is this script is run. under the context of the SQL administrator. So it can extract any kind of data that it wants to. It can connect to databases. It can do other malicious stuff like invite everyone to a donut party, send out emails. I'm not just kidding, but.
It's a German thing, I guess.
See, so far so good, right? We've kind of persisted our access there.
Just to interject there a second, can any of you figure out what protocol Lars used to copy that attack script in, whether it be a binary or a PowerShell script? He's got a console connection and he's on another host. He's using the magic of RDP copies from one environment to another. There could be an air gap between them, at least according to the VM configuration, which he just bridged solely because he's a Hyper-V admin. You tell me, how do you audit that? That's incredibly difficult to audit. I don't even know where I would put the audit log for that, other than every file copied onto the SQL server. That makes it even scarier to my mind.
Yep. So that is fairly easy, right? What we've seen so far is double-clicking, copy-pasting, and registry editing. That was the most sophisticated thing that we've shown so far. So now, I'm a Hyper-V administrator on this box. So basically, I can do almost anything that I want to the virtual machines actually running on that box. It's kind of obvious, right? That if they're not shielded, they're not protected against the Hyper-V administrator there. So let me just kick that off here. This is a small script just looking at the VM worker process ID that belongs to a particular VM. The VM worker process is a process that is hosting virtual devices for the virtual machine. And now what I can do with the key press here, I can simply attach a debugger to that process. And you can imagine if I can attach a debugger to the process hosting the virtual devices, I can simply dump the content there and try to get to whatever secrets are in there, right? That could be, I don't know, any keying material that is stored somehow, any other bits and pieces that are accessible there. So let me exit that, and I think
just switch it back
we'll switch over to...
So that attack vector there with attaching the debugger, effectively every single virtual machine running on a Hyper-V host is contained within a VMWP process, virtual machine worker process. What Lars did was attach a debugger to that and then use it to just start slurping up the memory content. It doesn't really matter what role that is. You can almost guarantee that there is a secret in there of some merit, of some value, especially if it were a domain controller. We can do all of these things, and is that security by obscurity? I would argue it is. It's security by rather complicated and sophisticated obscurity, but nonetheless, that is the only security that we've got protecting against this. That's insufficient. There are sophisticated users out there. I guarantee you most of the people on Lars's team and my team could execute that attack and do some really nasty things. All right, let's take a quick look then. So with Server 2016 Hyper-V, we get shielded VMs. This is the ability to protect a VM against every single one of those attack vectors, without fail. Not a single one of those attack vectors will work. So there's a little sentence there. I'm not going to read it out to you because that seems rather boring. It took me and the team quite literally minutes to come up with that. So there's a good amount of thought that went into this. But effectively what we're saying is this is a means by which you can deploy shielded VMs on fabrics that you have either some trust or no trust in, knowing that the virtual machine's assets cannot be attacked. They cannot be slurped up. The secrets will not be gained. So bare metal then versus regular VM versus shielded VM. A quick security comparison. If we look down the left-hand side, that's the bare metal box, physical. It's got a building perimeter with security guards and those stupid plastic gates that go up and down that you could drive through with a scooter. They appear to be effective, though. It's got boxes. It's got cages. It's got 2 padlocks. Why do we put 2 padlocks on cages? 1 key for one guy, 1 key for another. Collusion. Collusion is a very, very difficult thing to attain if you're the only malicious guy there and you're not sure if anybody wants to join you in your nefarious activities. So collusion is a hell of a way of ensuring that physical boxes are not accessed. So if you look down there, you can see the server admin has access to it. It's green because that's what's supposed to be. The server admin is supposed to have access to it. And the storage admin, the network admin, the backup admin, etc. do not have access to it. It's green because that's what it's supposed to be. Take a look at that for a regular virtual machine. Now, we say Hyper-V virtual machine, but it doesn't matter. It could be Citrix. It could be, what's the other one? Virtual Blocks. It could be, who's that other player? Their name escapes me. Oh, VMware, that's right. It could be a VMware server. We're all subject to the same attack vector. But as far as we know, we are now the only one in the industry that has the ability to put the defenses up, to put in place capabilities that are taken from proven technologies on bare metal, capabilities such as a trusted platform module, UEFI secure measured boot, and secure key release on file systems that are encrypted on the OS drive itself, not just data. And they are encrypted with keying material that is not available to the Fabric admin. So we'll keep on ticking through then. Here are our security assurance goals. We wanted encryption of data both at rest and in flight. Now, we're not talking about the workload data. If it's a domain controller and you're using LDAP, not LDAP-S, that is not encrypted. Well, it doesn't matter in AD. AD does use LDAP. Its messages are encrypted, so the message level encryption is still there. My point is we're not affecting the workloads traffic. We are affecting any traffic that is emitted by the fact that it's running on Hyper-V, live migration traffic. So when we live migrate one VM that is shielded to another host, we can do that still. All of that traffic is encrypted, and we ensure that the target host is healthy and therefore permitted to run this shielded VM before we even attempt the live migration. And obviously, data is encrypted at rest because the VHDX is natively encrypted using BitLocker capabilities within the guest operating system. Obviously, we want Fabric admins locked out. That's what I'm trying to persuade you we've achieved. We're very confident of that. And attestation of the host health is absolutely mandatory. You cannot run a shielded VM until you have passed attestation with a new service that is part and parcel of Windows Server 2016 called the Host Guardian Service, HGS for short. It does precisely two things. One is attestation, i.e. it measures something and then sends back a health certificate if it's good, or no certificate if it's not good. Once you've got a health certificate, you can ask it to release keys. And note at the bottom there, shielding is not intended as a defense against denial of service attacks. We thought about it where we could perhaps put an ACL and stop the admin from powering off the shielded VM. But if they're sufficiently diligent, all they're going to do is shut the box down. They still achieve the same end result, so it was a waste of our time. No point in doing it. Two modes of shielding exist. The first is called shielded. This is the super strong one. It is the one where you have partial trust in the Fabric infrastructure or no trust whatsoever. It's suitable for public cloud and private cloud use cases. The private cloud use cases would be where you're trying to separate duties. You want that strong segregation of duty between a Fabric admin and an Active Directory domain admin. This would provide that. The second one, we call it encryption supported. That's the second worst marketing banner that we've ever come up with. The first is MIMPAM. If you've heard of MIMPAM, has anyone heard of MIMPAM by show of hands? Yes, it's our privileged access management solution, and it's going out the door with the name of MIMPAM. Doesn't inspire confidence in me, and that name, it's a bit lame. We had others, but no one really sort of glowed onto one, so it ended up encryption supported. What's the difference? You use shielded, as I said, when you really don't trust the Fabric you want to run the VM on. You're actually looking for security. The prominent use case for encryption supported would be for compliance purposes. You need to check a box that says this workload is encrypted at rest. And if it's a virtual machine, it's encrypted in flight. I very much doubt the compliance bar gets to that level of granularity. But if you had, say, an example workload running on bare metal today, and it remained on bare metal because you could not virtualize it, because you could not check the box saying encrypted at rest, now you can. Move the workload into a shielded virtual machine, job done. You don't change the workload. You just run it inside the VM. And we have 5 or 6 separate, independently obtained compliance mapping tables for you. And I'll give you links to them at the end of this session. And I'll also show you what this does for you, just shielded VMs alone. OK. Who's it for, then? Pretty obvious. Hosters. I'm sure I don't need to explain to you why a hoster would find this interesting. If anybody would like to know, have a chat with Kenny at the front there. Kenny is from Bright Solid in Scotland, and as far as Kenny and I know, he is the first provider anywhere in the world to have a production-ready, I state ready because he hasn't got customers on it really yet, a production-ready guarded Fabric already pre-deployed, and he has a wealth of operational experience doing it. There was a session here this week that Kenny, myself, and Terry from Dell did that showed that solution, and it showed you all of the lessons that Kenny learned from operationalizing a deployment of a guarded Fabric relative to a non-guarded Fabric. I would wholeheartedly suggest you take a look at the streaming video for that. Obviously, tenants are going to like it because it allows them to meet a compliance bar, and you get the segregation of duty for enterprises. So this sort of backs up exactly what we just said. You deploy it as an enterprise private cloud, public cloud as a general hoster offering so that they have some level of sanity in terms of security and compliance bars they need to meet. Branch office scenarios would be another candidate. We often see people deploying read-only domain controllers in branch offices. Why? Because the physical security of the branch office cannot be maintained. There's nobody there doing it. It could be a single office out in the middle of nowhere on a high street. They are not going to put a domain controller with all of the secrets, all of the admin passwords in a machine that is subject to physical attack and walk-off. Somebody runs in and runs off with a domain controller. They haven't just got that little branch office, they've got the whole domain for the rest of the company, including the data center, head office, etc. So people deployed RODCs. How many of you have ever deployed a read-only domain controller? How many of you ever want to do it again? That's what I thought. That went from lots to none, by the way. Read-only domain controllers, great technology, but they turned out to be somewhat of a best practices nightmare. It was very, very difficult to maintain compat, and it ended up weakening what it set out to solve. Well, how about this? Put a Hyper-V system there, leave the host guardian service back in the data center, and run a shielded virtual domain controller, read-write. If somebody runs off with the Hyper-V server, doesn't matter. They can't power it up without the host guardian service saying thumbs up. So they can't use the VM. All right, moving swiftly on then to the next set of demonstrations. I've told you that the attacks go from simple through sophisticated and everything else in between. Lars showed you a really easy one. We call it the double-click attack. He then showed you the other one at the opposite side of that spectrum, a sophisticated attach debugger to the VMWP process. Well, does that mean that the user experience is also incredibly difficult? Well, let's see if Lars can prove to you which way that goes. Is it or is it not?
We'll see. So we'll actually start in that order. What you can see here is a VMM console of an environment that I created here as a nested environment. And you can see I have one existing VM, so it's very data center-like, I know. And the thing that you can do to shield this existing virtual machine is click this nice little shield icon here, up here. And then it asks you to select some shielding data. So that bears the question, what is shielding data? Shielding data is an encrypted blob, so to say, which contains some configuration data that the administrators of the guarded fabric should not see, right? Because if you want to be able to deploy a virtual machine in an environment where you don't really trust the administrators, you should have some secure way of putting configuration data in, like passwords for that virtual machine, like RDP certificates, for example, so you can make sure that only you can connect to that and that you're actually connecting to the right virtual machine that is owned by your company. And that is all contained in the shielding data file. So the tenant in the hosting case, or the VM owner, so to say, actually creates the shielding data file. I'll just go relatively quick into that. I'm not going to explain everything from this wizard here. I'm just showing how it's created in general. So you can say, I want to create a new shielding data file. You can have multiple, obviously, and each shielding data file contains different sets of configuration bits and pieces. The first thing that you need to do is you need to select who should be the owner, identified by a specific certificate that you have on your system. So you have your owner certificate, you select that, basically, and you say also which fabrics should be able to run this virtual machine. And you can select multiple fabrics, right? So you can have them run in your own private cloud. You can also have another guardian that you select there. A guardian is kind of a similar term for a guarded fabric. That is, for example, your disaster recovery hoster. When you use Hyper-V Replica and replicate that there, you would obtain their guardian information beforehand and also add that in this particular case here.
So if I could add something in there real quick. So far, Lars has run a graphical tool. He selected whether he was going to be creating shielding data for new VMs or whether he was going to use it to convert existing ones. Okay, so you've got those two options. He then selected whether it was shielded or encryption supported merely by clicking on radio buttons, gave it a name, and then he's come into a screen where you define who owns the VM and what guarded fabrics is it permitted to run on. That does require certificates, but you'll notice there's also a manage local guardians there. If you could click on that for a second for me, Lars.
Sure.
This is how you can create them within the UX.
If it comes up.
Did it take the click?
Dang, yeah. It's not responding. Let's see how long it takes. It should
you know what?
be there in a second.
I am so sick of demo gremlins this week. We have had nothing but problems with laptops. I'm going to bring a hulking great server next time with me.
Yes.
There you go. The UI finally came up.
Here we are.
This is how you create these Guardians. So I wanted to be clear here. You're not implementing a brand new workflow or process based upon an existing or new PKI deployment. You just click on some buttons and use self-signed certs if you deem that as sufficient. If you want to increase the security bar, then leverage certificates from your existing PKI. Your choice. But it's all handled via a GUI. I don't want you to think this part is any more complicated than the rest of it. Sorry, Lars.
Excellent.
Go ahead.
And to add on that, if you want, you can all do it all in PowerShell as well, right? So if you're like me, I like doing PowerShell, but there's a GUI as well. So the last part that I want to show you here in the shielding data file wizard, the last two pieces, is that you have the capability to select volume ID qualifiers, which, see, here we're back. Now, let me select that and click on Next, which is basically you defining what are the VM template disks that I trust, which makes a lot of sense, right? Because if you want to create a virtual machine in an environment where you don't trust anyone, you better make sure that you have a clean operating system. So if I, as a malicious admin, so I'm not really putting this on, just like that, would mount that template disk, and inject some malware, and then you created a trustworthy VM from that template disk. Is that really a trustworthy VM then?
Not when it's got malware inside it already, it isn't.
Yes, exactly. So the way that this works, basically, is you have signature catalog files that you can export. And let me just check where I put them.
So while he searches for those, effectively what we're saying here is the template disk is the attack vector for a malicious Fabric admin to use once they determine, OK, shielded VMs, I don't seem to be able to get into them. So why don't I try attacking them before they're born? Well, all VMs in managed fabrics like this are born from template disks. So all Lars is saying is we've got a mechanism that allows you to bless a template disk at a known healthy point in time by creating a very complex computed signature, a 2048-bit signature, which we wrap up in a volume signature catalog file and add to the shielding data. Did you find it? Oh,
yes, there is. So it shows you some information around who signed this particular template disk. And obviously, I created it, so I trust it. I can add it. And I can obviously add more disks there as well. So I don't need to create one shielding data file per operating system template disk that I want to use. I can just add all the template disks there, which I trust.
Cool.
Not going into the other details here, you can add more specialization values, like you can add a specific unattend file. You can inject your certificate that you want for using RDP, for example. You could also inject other scripts that you want to be running inside of that shielded virtual machine later on. The rest is just really next, satisfied, the file is created, right? So let me cancel that out. So I just hit OK. What it does then is basically power on the virtual machine, and it's BitLockering the disk, and it's making sure that all the shielding processes are kind of followed through.
Adding the VTPM device?
Yes, adding a VTPM device as well. That is true. Now, let me switch over to an even more complex part.
So there, just to clarify then, he used VMM, which is fully shielding enlightened. It understands every aspect, even to the extent of being able to deploy a brand new guarded Hyper-V host from the bare metal up. So VMM is fully enlightened to this. And he converted existing VMs. It's a process internally we refer to as grandfathering. I have no idea why, but we do. That's kind of handy, because if you've got thousands of VMs that you'd like to shield, you don't want us mandating that you redeploy them all. However, the assurances that we can provide against a VM that was converted are far lower than we can provide against a VM that was born secure. A shielded VM that was born as a shielded VM from a known good, blessed template disk. And that's what Lars is about to show you here. The UX is even easier.
Yes. So in the VMM demo, we had to explain all the concepts, right? Now you know what a shielding data file is, so that makes things a lot easier. We want to create a new shielded virtual machine. We want to create it from a gallery. So what you can see here is the genius of UX design. You have a small shielding icon. We have a shielding template. The thing that we need to select now is the shielding data. So I'm going to do the IT department here since I want to create a domain controller. One too much. Domain control, let's say. Let's do that. Even too long.
Hence the abbreviation DC.
I know. Like that.
There you go, that'll work.
Now I select the network, and then I hit OK. And it's going off, creating a new shielded virtual machine from template for us. And yeah, that's about it. Should show up in a second.
Fabulous. What the number is, though, I want to go back to
6.
7, I think.
Sorry.
OK. So we went through there, converting an existing VM. That's grandfathering. You can do it. We certainly wouldn't say it's not best practice to do it, because it's just not reasonable. You've got thousands of VMs. You want to adopt a guarded fabric. You migrate them in. Sure, we understand you're going to want to convert them. If it is, however, a super-sensitive workload in which you would like to be able to place the most faith, then deploy it as a shielded VM from birth, using shielding data and shielded template disks. You are the one that blesses them. The fabric can also bless them as well, if that's OK by you, but you can also bless those template disks by scanning the image yourself and generating a volume signature catalog of your own accord. We showed you that we can create a new shielded VM using Azure Pack. I think that was, what, 5 clicks?
Yes.
Maybe 5 clicks, selecting the shielding data, giving it a name less than 12 characters. And then obviously Lars has gone through and has showed you numerous attacks against VMs. So the next step is for Lars to show you how do those attacks look when we try them against a shielded VM. So why don't you go and try and attack our baby, Lars?
Yes, we'll do that. So, oh, hold on. I have to put that back on?
Yep, get the hat back on.
Nice. So you remember that window?
Can somebody take a picture, please, and email it to me?
So we got a second domain controller here. The thing is, you can still export it, right? I did that earlier, but just to prove the point here, we can export it to the temp folder in this case. While that's doing that, so you can still export a shielded virtual machine, right? But the data is still encrypted. That's the nice part about it. So let me go to the folder where I exported it earlier, which is the export DC and then the virtual hard disk part. And now what you'll see is hopefully an error message. Yes, there it is. Unlocked drive. The drive is BitLocker protected. I'm not able to mount it, right? So if I click on that now, you see the message that there are no supported protectors on this drive. That is the BitLocker key protectors, right? We have a lot of key protectors. So BitLocker key protectors in this particular case, what you could do for a shielded virtual machine, if you want to be nice, you can add a recovery key as well. So in case anything breaks, you can still get into that VHDX by entering the 46-digit recovery key, I think it is, right? So putting this hat back on. So yeah, I can't get to the offline data, right? That basically blocks me from obtaining the ntds.dit, so I can't get to the passwords. I can't offline inject any files there.
So which admins does that protect against? SAN admins, storage admins of any kind, and a Hyper-V admin trying to conduct or execute an offline attack doing what Lars just did by exporting it and then attacking the resulting disk, which has been put into a consistent state. We did everything to help you, but they still can't gain access to the data because the key is sealed to the TPM boot measurements of the guest shielded VM from which that disk was obtained. The keys aren't known to us as the Fabric admins, not even with the silly hound.
Now let's assume somehow I've obtained a local credential for my host, right? What I could do is simply open the VM console and try to enter this there, but unfortunately I can't, or fortunately I can't. For me, as the bad German attacker, I can't, and that's unfortunate for me, but for everyone else is good. For shielded virtual machines, we block console connections. So we block a few other things, which are mostly referable to as admin conveniences, right? Anything that could be used by a malicious administrator to get to the data inside of that shielded virtual machine, we're trying to block out. The last part is this. Just hit enter. It's as nice as that. We have a VM worker process as well, but if I try to attach the debugger there, I can't because it's running as a protected process. And as an administrator, I can't attach a debugger to a protected process. So basically locked out there as well.
Great. Thank you very much. So you've now seen that we can't gain access to it offline. We can't gain access to it online. We can't use console connections. There's a laundry list of things you can't do: KBP Exchange, file integration copy components, PowerShell Direct, console connections, attach a debugger. But all of these things require that the host be doing things in the manner in which we intended. What if somebody attacks the host to make it do things in a manner which we did not intend, i.e. just throw all the security away? That's why we have the attestation service. The attestation service ensures that a trusted admin, ideally one of you, deploy a Hyper-V host with a perfect configuration, no malware, no viruses, any agents on there that you deemed necessary. At that point, you extract the baseline from it. We refer to it as the baseline for the boot. We're basically taking measurements as it goes through its boot path, and then we're then recording those into a baseline. And then when it requests keys, the Hyper-V host requests a key to power a shielded VM on, it has to first go through this health attestation. And I'll walk you through that in a second. All right, so we also have third-party Fabric Manager support. We've mentioned that VMM supports it. We've mentioned that Azure Pack supports it. Both are fully enlightened, VMM even to the extent of being able to deploy guarded hosts from bare metal upwards. PowerShell is also there. You do not require VMM. You do not require Azure Pack. You can do this entirely in PowerShell if you choose. It is far more like building a house brick by brick yourself, because it's PowerShell being used almost as an API. And we can see here that we've got third-party Fabric Managers, which Lars is going to show you, have already built on top of that API to provide support for shielded VMs in a third-party Fabric Manager.
OK. So if you click, then we're going to show a quick video recording of that. So what happens is basically we have an existing shielded VM template. And what you see now is basically the process of creating a new VM based on that template. So we enter the instance name similar to the WAP case. In this case, yeah, they don't have the character limitations there, so it wouldn't run into that. They select the shielded template and configure a few other bits and pieces, like which computer name and which time zone, for example, should be used, and then go ahead in the end and launch the instance. So we have the computer name and the time zone will come up next. And basically, it's a similar experience, right? It's yeah, more fine granular control, I'd say, than what we have in WAP. But here it comes. It's creating a new shielded virtual machine. And we'll open up Hyper-V Manager to simply show that it's actually running shielded on this particular host. So you can do OpenStack with the next Nova release. I think that is coming up in October, the next RTM release there. And yeah, I just want to thank our friends at Cloudbase for helping out there and for adding the support to
Excellent.
OpenStack.
And we're also working with other third-party Fabric Managers, so if there's another one out that you use, please feel free to mail me, dean.wells@microsoft.com. We are working with as many as we think makes sense to try and get them to enable support for guarded fabrics as well. All right, can I advance from this? Yes, I can. So let's take a quick look then at the security model. How exactly does all this stuff bolt together? Well, I mentioned to you earlier on this notion of a new role called the Host Guardian Service. So let's give you the bare minimum requirements for you to deploy a guarded fabric. You need to have at least one Windows Server 2016 Data Center Edition host. Has to be data center. It's the only one that supports shielding. You have to have at least one running the Host Guardian service. That's any Windows Server 2016 SKU with the exception of Nano, and it can run on top of just about any old hardware. The Hyper-V host is a little bit different. The Hyper-V host can run on somewhat legacy hardware, but if you want to use our strongest attestation model, it requires physical TPM v2s. TPM v2 is very, very new. The first machines were only released in December of last year. So there are a lot of machines out there that don't have this capability. The reason that Dell participated with Kenny and I in the session earlier this week is because they are, as far as I know, the only company that is offering a field service upgrade of the TPM 1.2 to TPM 2 so that you don't have to just throw all of the fabric stuff away. But it is constrained to certain models. So I'm going to work on the assumption that TPM attestation is the one that is most important to folks. But I do want to say, if you've already got a fabric and shielded VMs seem like that would be a great candidate for you to upgrade to Windows 2016 for, then you can deploy without TPM v2. We call it admin trusted attestation, but you lose a lot of the assurances because we cannot measure the health of the host anymore. We can no longer measure the health of the host without TPM v2. We measure its presence in an Active Directory group. So you authorize it to run shielded VMs by adding its computer account in AD to a group and then tell the host guardian service that SID of that group, the security identifier, is trustworthy. Then when it tries to power on a shielded VM, it will go and ask the host guardian service for the keying material to do that. The host guardian will challenge, and it will use Kerberos session tickets to authenticate itself. We then extract the SID from the session tickets pack attribute, compare it to the blessed security identifier, and you're good to go. There are so many attack vectors in that mode. Is it better than a regular VM? Oh, hell yeah. It still protects against offline attacks. You've still got secure measured boot going on in the VM. You've still got VTPMs there. But it's rife with other attack vectors. How about I attack Kerberos? How about I attack Active Directory? How about I put malware on the Hyper-V host? All possible with admin trusted mode. So we consider it as a temporary state while you march toward TPM-based attestation. So you could deploy this the moment Server 2016 is released, probably on the hardware that you've got merely by upgrading the OS, and then start steadily marching toward TPM v2 deployments, at which point you throw a switch and convert the fabric from admin mode to TPM. You do not have to redeploy. You simply pre-configure the TPM state, which is things like endorsement keys from the TPM. We use those as identifiers, the baselines that I mentioned earlier on, and a code integrity policy. You do that once for every kind of platform that you've got, and obviously the endorsement key from each Hyper-V host that is permitted, you have to take that from every machine. It's just a series of steps. When you believe you have done it, you run one commandlet and you switch it to TPM mode. You test if it works. If it works, you tear down the Active Directory trust and leave it as is. If it doesn't work, you switch it straight back to admin mode and figure out what the heck went wrong. OK, so you've seen here that Hyper-V host 1 said, please, sir, can I have some more keys? A little bit of a reference there to Oliver Twist. And host guardian service says, why, certainly I know you, and I must say you're looking terribly healthy today. At which point, it passes over a certificate of health. That certificate of health lasts for 8 hours, and it permits the Hyper-V host to make requests for keys. Now, what was it that the host guardian measured? What did it measure to say that you are healthy? OK, now I'm going to go through this because this is a 300-level session that you chose to attend. So don't tell me it went too technical in the reviews if you don't want to attend a 300-level session. Right, so here's what happened. The actual stuff going under the covers, I don't expect you to walk out of here and remember this. I want you to understand how much investment we made in getting this right. So how many of you know how secure measured boot works? Oh, good. All right, so here's how secure measured boot works. It's UEFI firmware. What it does is it has a TPM, and that TPM is measuring values. So as the machine boots, the firmware is the first thing that loads, right? We all know that, and then it begins a bootstrapper. It then hands control to a Windows OS loader, but it has to know the OS loader. It looks at the signature of the OS loader and says, is that signed with a certificate that exists in my whitelist and is not in my blacklist, called DB and DBX in UEFI firmware. If it exists in the whitelist and not in the blacklist, then it goes, right, my job's done. Hand control to the Windows OS loader. The Windows OS loader has a hash extracted from it that is then recorded in a TPM, into a little register in a TPM. The OS loader then knows what the next binary in the boot chain is. So it hashes that binary and compares it to a known list of what should be coming next. And it says, yes, that hash lines up, at which point we extend the hash in that memory value, the PCR, within the TPM. Extending a hash means I take the current hash, I add the other hash on the end, and then I hash those two values again to end up with one unique hash representing the state of those two hashes. And I repeat this process ad nauseum until the entire OS is up and running. The end of that means I've got a value now, a measurement, in 1 or 2 or 3 PCRs in the TPM of that host. At that point, that's where you go, seal a key, the BitLocker keys. You now say seal the BitLocker full volume encryption key to that specific set of measurements. The only way that you can ask the TPM to release that key the next time around is if the exact same measurements line up. If you asked it to release the BitLocker key and the measurements were not the same, what do you think the TPM is going to say? And are TPMs difficult to attack? Yes, they were designed that way. If you try and extract them from a motherboard, they are designed to be fragile. They will break. They are designed to be as impermeable as is possible in the silicon architecture. So we use UEFI Secure Measured Boot. We record all of those things into a trustworthy computing group log file called the TCG log. So the first step was when Hyper-V host came up and then it extracted its own TCG log. It then said, give me the keys to power on Shielded Virtual Machine 1. The host says, who the hell are you? And the Hyper-V host says, here's my endorsement key, a public key from its TPM. So there's a key pair that is unique to every TPM out there. It sends back the public one. The Hyper-V host has an identity now that is far stronger than that of a domain-joined relationship. It is a hardware-based, immutable identity. That is recorded because it was pre-introduced to the fabric by Lars, our fabric admin. He said that this is a blessed host. The host guardian server admin, which would be a separate guy from Lars, it would be me. I'm far more trustworthy, obviously, seeing as I'm British and you can trust us. Okay, whatever, I'll just ignore you. So they introduced that endorsement key. That is how I identify the Hyper-V host. So we said, who are you? And he goes, hi, Batman. No, he didn't. He said, who are you? And he gives back his endorsement key. He now knows that that is Hyper-V host 1. He then says, give me your TCG log. I want to compare it to my whitelist. He looks at the TCG log, which is very small, and he compares it to a known good set of whitelisted baselines on his disk, in his database. Again, it would have been me and Lars working in conjunction with one another, him as the fabric admin, me as the HGS admin. They must be separate. We would work in conjunction to get that known healthy TCG log. I compare it, and it looks good. But what if the Hyper-V host lied? What if it lied to me? And it just gave me a TCG log that looks good, but it isn't actually the one that it just generated because it's running malware. So what we do is we tear the TCG log apart, and every step in there was recorded. The handoff to the OS loader to the next binary, the next binary, the next binary. So what we do on the HGS is we literally recompute the value that should exist in the TPM on the Hyper-V host. We then go running back over to the TPM on the Hyper-V host, and we say, give me the value from that PCR, and sign it with your private key. So now I know that it actually came out of the TPM. It wasn't faked, it wasn't fictitious, it wasn't malware. I know it came out of the TPM because I've got the public key of the TPM, and I use that for its identity. The private key is the opposite half. They're cryptographically opposite. We sign that, and then we compare the two values. If the TCG log values look the same, the measurements, then I know who you are with an immutable identifier from a TPM. I know what you booted and that it was a blessed boot sequence, a baseline. I know you didn't lie to me about that boot sequence. That's what we know so far. Finally, we ask it, give me your hypervisor-enforced code integrity policy. And I compare that to a known hypervisor-enforced code integrity policy also stored on the host guardian service. That prevents people from running malware or any tooling or utility or driver that we don't specifically bless. So at that point, we know who you are, we know what you did when you booted, we know you didn't lie to me about what you did when you booted, and we know you've got a code integrity policy that we believe to be sound. That's what I refer to as rigorous attestation. That process is quite complicated to describe, as you can imagine. If any of you have actually got all that in your head, well done. My goal is I'm not trying to educate you so you do get that in your head now. I'm trying to give you a sense of how much security went into this. But remember the UX, remember the user experience. The security is under the covers. Kerberos is also a monumentally complicated thing to implement, but we consider Kerberos easy to use now because we've covered it up with UX and we've made it easy to implement. The same is true here. All right, at which point, sure, your certificate of health authorizes me to release keys to you. He sends the key over and the shielded VM powers on. The key was digested by virtual secure mode because when the key came back from the host guardian service, it was encrypted to that machine's virtual secure mode. So it still isn't visible on the wire, and it sure as hell isn't visible to a fabric admin running on that Hyper-V host or malware that somehow is running there. I have no idea how the heck it could be running there, but let's say it was, some magic exploit. It still wouldn't be visible. They'd have to break the security that we've built on top of virtualization-based platform technologies that we refer to as virtual secure mode. All right, hopefully I managed to persuade you that this is indeed rigorous in terms of the way we make sure this implementation is bolted up from end to end. So I mentioned earlier two attestation modes rather, admin trusted and TPM trusted. Admin trusted is about initial adoption simplification. Any of you now that run fabrics with at least 2012 R2 Hyper-V would be able to upgrade to Server 2016 data center almost without fail, and you would be able to build a guarded fabric. And you could run in admin trusted mode. If you want to get to TPM mode, you have to start buying hardware that has TPM v2 inside it. And then you get all of the security that I just mentioned, which, as you can imagine, based on what I just explained to you, is far stronger than merely checking the membership in a computer's group. The two are leaps and bounds apart. They are wildly different, but they both give you VTPM. They both give you shielded virtual machines. They both give you encryption-supported and shielded mode. They both allow you to encrypt the data at rest and in flight. The difference is the attack vector on the host side. TPM is incredibly difficult to penetrate. I'm not even sure that we know of a particular path of doing so at this point. So here's the trust chain. If you use TPM trusted attestation, we are basically saying that a guarded host uses UEFI, UEFI firmware, with its TPM, using trusted measured boots and code integrity policies, which it measures off against a host guardian service before it's authorized to power up a shielded VM, which, guess what, goes and does the same thing again. It uses UEFI secure measured boot, takes its own boot measurement, seals its BitLocker key to its own VTPM. The one part in here that we haven't touched on is, how is the VTPM itself secured? The trust that we place in physical TPMs is by virtue of their silicone nature. They are a real pain in the ass to get inside to attack, because if you try and scrape it off the motherboard, you break it. If you would try to attack it while it's on the motherboard, well, it can defend itself. How do we do that with a synthetic TPM? Well, the way that we do it is the TPM itself is encrypted while the virtual machine is powered off. So it lies on the disk, and it is encrypted with a key that only the host guardian service can properly release. The host guardian service will only release that key if the host is known to be healthy. So we're thumbs up there. But what about during runtime? What about if Lars tried to attach a debugger to the VTPM codebase? Well, the VTPM runs as a cutesy term, which is where marketing did not get their hands on this. We did. We call it a trustlet. Like a commandlet for PowerShell, we have trustlets. Trustlets run inside virtual secure mode. There are, 6, I think, available today. They're all Microsoft-owned. They're used by things like Device Guard and Hypervisor Enforced Code Integrity, and they are also used by our VTPM. So the VTPM device actually runs in VSM, meaning that the technologies that we use to protect virtual machine 1 from an attack from virtual machine 2, we know that that doesn't happen. We all trust the fact that virtualization has security safeguards to prevent one machine, virtual machine, from attacking another. We're using that same technology to stop things from attacking virtual secure mode. That's where the VTPM runs. So as long as the host is healthy, we have the ability to place a strong level of trust in it. Therefore, the VTPM itself is also protected because we know it's running trustworthy binaries that are doing what we intended for them to do. If you take a look at the trust chain in admin mode, you can see that the guarded host has no trust chain. It is all about membership in the correct AD group. But do you still get TPM in the guest? Yes, you do. Do you still get secure measured boot in the guest? Yes, you do. But the attack vectors are far wider and far simpler. Again, we're not really clear on an attack vector that is viable for a TPM. If any of you want to immerse the Hyper-V host in liquid nitrogen and then start scraping the layers of silicone off the top of the TPM, give that a go. See if you can figure out the orientation of the bits. That's literally what that attack is. We refer to those as mission impossible attack vectors. So if you've got some, please let us know. Maybe we can do something to thwart them.
One thing to add, though, there, the axes in the upper left corner do not mean that you can't use those technologies, right? You can still use Device Guard. You can still use code integrity policies, obviously, but they're not part of the trust chain for that specific virtual machine.
Good point.
So you can raise the bar, but not as much as you have with TPM 2.0.
I think that is a great point that he just raised there. What Lars is pointing out is that I made it sound as though you can't use the technologies, that in TPM mode, we both use them and measure them. Lars is pointing out that you can use them in this mode, but we don't measure them. That's the delta between the two. Yeah, good addition. Thank you.
Awesome.
All right, back to you. What are you going to do now? Oh, right, he's going to walk you through a transition that we believe many of you will take if you decide to deploy Guarded Fabric. That transition is, well, you're going to deploy in admin mode first, so at some point you've got to pre-configure it for TPM mode and then throw the switch. All yours, Lars.
Nice, thanks. There we go. So
you might want to zoom in or increase the font size.
So I have to say, on the right-hand side, you don't really have to be able to read that. That is just my cheat sheet because I don't want to fat finger any of the commandlets there. What I'm doing now is basically, the few steps that we have. The first thing that I'm going to do is I'm going to create a new code integrity policy. And that is basically running a commandlet. I can kick that off because it's taking some time, and I don't really want to let that finish, but I'm still kicking it off.
Actually, let me refresh your memories on the 3 things that we needed. First?
Code integrity policy.
Second?
The TCG lock, the baseline.
The baseline. And third, a way to immutably identify hosts that are trustworthy by storing their endorsement public key from their TPM. All Lars is showing you right now is how to extract those 3 things, because none of them have been in play up until now, because his fabric is running in admin trusted mode. He now wants it to be far more secure because he has hardware that supports TPM v2. And he's literally showing you how you would do this, so this is probably interesting for those of you that want to actually deploy a guarded fabric.
Awesome, thanks. The thing, this commandlet, or the status text here is serious, right? Scanning, this might take a while. It would really take some time because the guarded host that I'm running here right now is a server core installation. It would be a lot faster with Nano Server, so I'm actually going to cancel that. I prepared that earlier as well, the code integrity policy. So when do you have to do that? When do you have to create a new code integrity policy? You create a new code integrity policy whenever you deploy a new operating system or a new operating systems queue, right? So I have to create one for my Windows Server core, or the Windows Server 2016 server core installation here. And what I'm doing is I'm leveraging file publisher rules. So it goes through every single file in my installed operating system, checks whether it's signed, and extracts the publisher information. And then afterwards, the next thing that I would run is this part here. The first commandlet spits out a huge XML file. And what I'm doing then is simply compiling that into a binary file, into a certificate, or into a signed bit here, where I'm converting the XML file, where I'm combining all these rules into one single set of code integrity policy. I can still keep the XML file around in case I want to add things later on. I would be able to manipulate that and use that as a starting point. But as I said, I already prepared the original code integrity policy. I already did the compilation bit and piece. So I'll go on to the next bit and piece. What I'm doing next is I'm going to apply this code integrity policy to the local host, merely by copying the compiled code integrity policy file into the directory C Windows System 32 code integrity, and it has a particular name. When I reboot this host now, it'll go ahead and apply the code integrity policy. I'm just closing that because I can then reopen it with my nice shortcut here. Let's give it just 1 second, and we can open it up again. So the code integrity policy is applied now, and now I can go ahead and create my baseline attestation policy. What that does is it reaches out to the TPM module. And obviously, I already created that, so I'm going to overwrite that. It reaches out to the TPM module and says, OK, now give me your TCG log. Give me all the information that you accumulated during your boot process about what you booted, how you're configured. This is the second part. And I have to do that for every machine type that I'm deploying in my environment. So I'm using a kind of golden machine here. Say, this is my role model trustworthy host, and I'm capturing the TCG log for this particular host. The last thing, what was it, Dean?
The endorsement key, the EKPub.
Nice. EKPub, there we go. How that works is we have a simple commandlet which writes out the EKPub key with some other information to an XML file. And I'm simply moving all these files now to my host guardian service later on. This bit, the EKPub extraction, you need to do that for every single host that you add, right? Similar to in the Active Directory case, you would add the particular host to the AD group. This is the equivalent. You obtain the EK pub and register it with the host guardian service. Right? All right. So
Let's go ahead and convert it then, because we're running low on time.
Yes, I'm converting it. So switching over to the host guardian service then. The host guardian service is nice and blue, and I already have the right files over here. Oh, no, I don't have the right files over here, but I'm simply lazy and am connecting now to the server. So if I look at the directory there, you can see all the files that we created, right? We have the TCG log baseline, we have the code integrity policy, and we have 2 compute hosts identities here. So what do we need to do? We need to first register our baseline. I didn't mean to copy that. I meant to copy this bit. Nice. So as you can see, there's a warning here. The HDS is currently still running in AD trusted mode. So it's still continuing to check the host health based on Active Directory. But what I'm doing now is I'm preparing the switch over to the TPM trusted mode. So I've added this baseline. I'm now adding the 2 hosts. Again, the same warning. We're still running in AD trusted. And I'm adding the code integrity policy. That's it. And now I'm being a good citizen and remove the PS drive first. And the last part, I run set HDS server trust TPM, which is now the cutover. So now it's changing its configuration. And I can run get HDS server to show that it is indeed now operating in attestation mode for TPMs.
Let's jump back in because we've got a few more slides to do.
Sure.
We're going to have to cut that one demo short.
Yeah.
OK, so Lars showed you how to pre-configure the fabric for TPM trusted attestation. So the admin trusted mode is incredibly simple. It's just a group in AD. The part that Lars went through, you would do the EKPub once for every new TPM v2 Hyper-V host. You would take the baseline only once for every OS on every platform. So what I mean by that is if you had Server 2016 Data Ascent Edition running on Dells, then you would have to take a baseline from there. If you also had it running on Hewlett-Packards or somebody else, you would have to take a baseline there. You then take the Hyper-V code integrity policy from one of the same representative machines, because they will differ according to the drivers of the HP and the drivers for the Dell. Other than that, he uploaded them to the host guardian service, added them to the whitelist database, and then converted the mode. Job done. All right, so a few spotlights then. Shielded virtual machines only support Generation 2 VMs. You could state that the other way around if you like. Generation 2 VMs are the only ones that can be shielded. Hyper-V host must be Data Center Edition of Server 2016. Shielded guests. We can't go as far back as Server 2008 R2. We can go back as far as Server 2012. 2012 R2, Win 8, Win 8.1, and obviously Server 2016. And we are also working on support for Linux. Lars and I were planning on demoing, but we didn't end up with enough demo to be bothered to show you at this point. Very, very close, but we're still working hard to make sure that we will support Linux shielded VMs. The time frame is a little bit unknown because there are some wheels that move slowly in the open source community, as do wheels in Microsoft, but that's slowing us down, so it's a bit difficult to predict a date. But ultimately, it will come. Last but not least, the VTPM inside the shielded guest machine is not tied to a physical TPM in any way, shape, or form. There is no relationship between them. That is proven by the fact that if you configure a fabric in admin trusted mode, it doesn't even have to have a TPM in the host. There could be no TPM at all. This thing is entirely synthetic. The TPM in the host is a recommendation solely because you can then use it to use secure measured boot and seal BitLocker keys. It has nothing to do with the VTPM in the guest, entirely unrelated, thereby permitting live migration to occur. All right, so we said earlier that there are a number of things, these admin conveniences, that get disabled. You can see the list here. It is lengthy. VM Connect, PowerShell Direct, Remote FX, some WMI calls, KVP exchanges, specific ones are disabled. Guest file copy, integration component, disabled. No registry hive injection. All of that stuff is switched off for shielded VMs. That is not switched off for encryption-supported VMs in almost all cases. So encryption-supported VMs give you the ability to still use console connections. Requirements at a glance, then. We need a host guardian service. We typically recommend a 3-node cluster running on Server 2016 bare metal. Very, very simple to build. In terms of scale requirement, whatever you would apply as a suitable scale unit today for a domain controller is roughly applicable here. That's the easiest way I can convey it to you. We successfully had 800+ attestation events in flight, in parallel, against a single host guardian service on commodity server hardware, and none of them timed out. It wasn't instantaneous. There were a number of seconds that ticked past before the attestation event completed successfully, but nonetheless, we did 800. So you can imagine the scale. It's not particularly large. Obviously, you need guarded hosts, and we've said that you have to have Server 2016 Data Center Edition. If you want to use TPM attestation mode, you have to have TPM v2. If you don't, then we would recommend you have TPM v1.2 to at least encrypt their disks and use secure measured boot there. But you don't have to. That's just best practice. And then optionally, you can have fabric managers, either OpenStack, VMM, and Azure Pack. Your choice. You can do it all without them. This slide I'm not going to walk you through. This slide is here so that you can review the PowerPoint after the fact and divide down these administrative tasks into the separate personas. You'll see on the left that we say this is what the hoster and the IT staff has to do. Then below, in phase 2, this is hoster and fabric admin. Finally, tenant and IT security staff, and then tenant and VM owners. The idea of this is so you get a good sense of where the admin tools run and who runs them. What do you need to do if you wanted to build a proof of concept, which is the same sort of thing that we're running up here? Well, you need a pretty hulking great virtual machine, preferably one that doesn't actually hurt your back to carry it, a single system, 32 gigs of RAM, and Server 2016 Hyper-V compatible hardware. The way that we're running this is we have the host, the bare metal laptop, running on Windows 10 Anniversary Edition with Hyper-V installed. It then has a honking great VM inside it that runs the rest. Or you can run some of it on the host and some of it inside the nested virtualization. You don't even have to have TPM v2 in the bare metal. Why not? Well, what is the synthetic TPM, the vTPM? v2. So you can actually create a VM with a synthetic TPM v2 that thinks it can now run Hyper-V host guarded with TPM-based attestation mode, even if you don't have a TPM in the host period. So it's kind of a cool thing to be able to do, which is why we decided to put that up there for you. Last, but certainly not least, this is the compliance mapping that I mentioned earlier on. We've created these tables for just-in-time administration, just-enough administration, those are examples, and obviously here for Shielded VM. All of these decks will be available for you to download, so you don't need to worry too much about taking pictures. They'll all be available for you, but you're more than welcome to. So if you want to hit that PCI, the Payment Card Industry Compliance bar, simply run the workload as a Shielded VM, job done. So the key takeaways, this is what Lars and I came up with as what we wanted you to walk out of the room with. Owners of VMs get to protect their data against both online and offline attacks. Fantastic, that's what we needed. The Fabric admins are no longer a threat. They are locked out, it's a black box. If it's shielded, it's a black box. If it's encryption supported, well, they can still console connection. Very different use cases, different scenarios. The health of Fabric hosts must be measured. I don't think I could be persuaded that any third party that claims they can do what we do here without measuring rigorously the health of the host, that is not a fully backed claim, because the host is only as trustworthy as the binaries running on it. If they've managed to replace a significant piece of the hypervisor infrastructure with malware that subverts the general runtime of that service and starts stealing keys and leaking them, then all the faith that you have in shielded VMs is gone out the door. This is why there was so much effort into ensuring that the host remains healthy, was born healthy, and the same for the shielded VMs. It is absolutely essential that that be in there. Shielded VMs run only on approved guarded fabrics. We showed you how you do that when you create the shielding data. So you could have it running on your private cloud. You could have perhaps Bright Solid, because they're the only ones I know of with a guarded fabric in a production environment. You could have Bright Solid as a DR site. So if something was known to be going wrong with your current data center, you could have it automatically migrate into Bright Solid, and as long as you configured the shielding data and the key protector to permit the Bright Solid guarded fabric, your shielded VM will transfer there, and it will allow itself to be run there. When you're done, you bring it back home. You can specify as many guarded fabrics as you see fit. Protections are rooted in hardware. We claim that same statement, even for the synthetic TPM, as long as you're in TPM attestation mode. The reason we make that claim is because by a series of rigorous events that happen, measurements, and then additional policies, code integrity policies, etc., that VTPM is a useless encrypted lump of nothing until such time as a piece of hardware has said that you are allowed to decrypt this. Those keys that are allowed to decrypt that should be, per our recommendation, backed by a hardware security module, an HSM. So in an ideal configuration mode, your host guardian service would be a 3-node bare metal cluster using encrypted disks locked in a cage with 2 padlocks and a camera pointing at it. It's managed by folks that are not the fabric admins and not the corp admins. And you attach a hardware security module in it, and you extract certificates from there. The private keys never leave the HSM. That way, we can make the claim that the VTPM is also rooted in silicon by a series of rigorous measurements. Likely deployment scenarios, enterprise private cloud, public cloud obviously, branch office for the read-only domain controller. We can stop doing that now and put read-write domain controllers there. Comfortable in the knowledge that if somebody runs in, breaks the glass, steals the box under the secretary's desk, for example, and runs back out, they've got a box of shielded, encrypted nothing, they can't run it. And lastly, for compliance. So there were a number of related sessions. All of them are earlier from this week, but I've left the codes up there for you so that you can, the titles up there for you, rather, and the codes so that you can go and download them after the fact. So thank you very much for your attention. Please do evaluate the session. Let us know what you thought. And if you've got any questions, please feel free to come up and ask them.